Solving examination questions. Number one, we need to read the question carefully and underline or highlight the important points. Underline statements like same mass, same force, object starts from rest, object come to rest, or the mass is 690 kilograms, etc. Number two, take note of the number of marks provided so that you will roughly know the number of points and the length of the response needed. Number three, identify the variables given and ask to help you choose the formula to solve the problem. Number four, we will use the following steps to solve questions involving uniform circular motion. First step. Step one, we draw a free body diagram for the situation. In step two, we identify the center of the circular motion. This is because there is a resultant force directed towards the point. In step three, we apply Newton's second law, F equals ma, to solve the problem. Identify all the forces acting on the object, and the resultant of these forces acting towards the center is the centripetal force or the resultant force F. Remember that F is just the resultant force that acts on the object performing uniform circular motion. We do not show the centripetal force in the free body diagram. In step 4, we will follow step 1 to 3 to solve questions. There are few questions for uniform circular motion because the ideas are tested in other topics like electric field, gravitational field, and magnetic field. This is a question from October, November 2021, variant 41. In part A, with reference to velocity and acceleration, describe uniform circular motion. The question carries 2 marks. Therefore, you must have 2 points, 1 point for the velocity and 1 point for the acceleration. Uniform means constant. The problem is what is constant here. And then circular motion means moving in a circle. To do this question, you need to understand that velocity is a vector quantity. It has both magnitude as well as direction. Assuming that the car moves along path X, the circle of the circular motion is O here. When the car in following path X reaches A, the magnitude of the velocity is 94 meters per second, and the direction of the velocity is towards the left. When the car continues to move and reaches B along path X, the magnitude remains constant at 94 meters per second. However, at D, the direction of the velocity has changed from the left to the right. Therefore, when the car moves in a circle, the velocity is changing all the time because the direction is changing. This change in velocity causes the object to have an acceleration. The acceleration is known as centripetal acceleration. It is always directed towards the O, or you can say that the centripetal acceleration is perpendicular to the velocity. So the answer for this question is written in red here. In part B, 2 cars are moving around a horizontal circular track. One car follows path X and the other car follows path Y. The radius of path X is 318 meters, and the radius for path Y is 345 meters. Both cars have the same mass, which is 790 kilograms. The maximum lateral or sideways friction force F that the cars can experience without sliding is the same for both cars. So 2 things you can derive from this passage. Number 1, F and M are constant. The value of M is given to you. Number 1. Number 2, the centripetal force is provided for by the friction force F. The free body diagram for the car is given here. There are 2 forces acting vertically. The normal reaction force acting upward and the weight acting downward. The normal reaction force, is equal magnitude but opposite in direction to the weight. Therefore, there's no resultant force in the vertical direction. However, there is an unbalanced force F acting towards O. This unbalanced force is the force that provides the centripetal force. In part 1, we have to calculate the maximum speed at which the car on path X can move without sliding. Sorry, we have to calculate the force. And we are given R, M, and V. And we want to calculate F. So the formula that you have to use will have to contain R, M, V, and F. So the formula that we choose is F equals to mv squared over R. F is a centripetal force, frictional force. M is the mass of the car. V squared over R is a centripetal acceleration. Stating the formulas in the question will carry 1 mark. And then substituting the values into the equation to give you 32,000 Newton will carry the other mark. In part 2 of this question, both cars move around the track. Each car has a maximum speed at which it can move without sliding. You have to complete table 1.1 by placing 1 tick in each row. For the row on centripetal acceleration, which is labeled as A, the formula used to discuss the question is F equals ma. This is because you're given F and M, and you're asked to find what happened to A. F and M are constant as indicated in the question. Therefore, your A is a constant based on the formula. Then for maximum speed, the formula uses mv squared over R. You're given F and M, and you want to find the relationship between the radius and the velocity. F and M are constant, hence your V squared is proportional to the radius R. So when R increases, your V also increases, which is why you put the tick here. You can also use the formula F equals to mv squared over R to calculate the maximum speed if the car follows path Y. Substituting the values into the equation will give you Vy, the velocity for maximum speed for Y, path Y is 98 meters per second, which is larger than the maximum speed if the car follows path X, 94 meters per second. Then for C, the time taken for 1 lap of the track is the same as the period. So you are given Fm, and you have to find the relationship between R and T. R is the radius, T is the period. So the formula you use is A equals to V squared R, V squared over R, and V equals to 2 pi R over T. Or you can use A equals to R omega squared, and omega equals to 2 pi over T. So you simplify the equation, A equals to 4 pi squared R over T squared. Since A is a constant, your T squared will be proportional to R, which means when your R increase, your T increase, which is why you put the tick here. You can subscribe to the e-video which I have prepared to learn more about the theories of the chapters and also to learn more about the techniques to solve examination questions. The e-video lessons are currently on promotion for a limited time period. The introductory price for the full package is USD $150 only. Subscription to the package will give you access to the A-level materials and support you might need to prepare for the examinations.